Hello everybody, welcome to this video. In this module, we are going to delve into residual stress analysis and welding. So in this module, you are going to learn the residual stress theory, what does this residual stress come from, how can we deal with it, how can we modify it, and you're going to learn how to do residual stress analysis of a MMAW, which is manual metal arc welding, and also we are going to post-process. We're going to look at the results and we are going to plot them and do such cool things. So to kick off, what is residual stress? The residual stresses are the stresses that remain in the material after the welding was complete and the material is cooled down to the room temperature. These residual stresses can cause distortion in the materials, and they usually came from the non-uniform heating and cooling in the material, because the welding process is a very fast and rapid process. The cooling down and the heating and cooling down are non-uniform. It is not a transient process, so that causes residual stresses. Okay, the schematic of the residual stress is like this. Actually, it's like the figures of delta T and the stress. So imagine we are here in the line A, which is the base metal. As you see here, delta T is 0, so it means it is not affected by the weld. Then we have no residual stresses. Here, while the weld is hot and delta T is high, we see that the stresses are in this figure, something like this. This is not high, but this is a very low stress because the material is still hot. And here, away from the weld pool, in the section C, we see delta T is lower and the residual stresses are like this. If we move from here to here, we see the high stress is in the middle and the cooled down regions are kind of having the negative stresses here, but here we have the tensile stresses in the middle of the weld. And here in the section D, where the temperature is the delta T is 0, it means the material is cooled down. The weld started from here and here is cooled down. We see high residual stresses in the material. So that's what happens inside a weld. Alright, what causes residual stresses in welding? The first and foremost is thermal expansion and contraction heating. So during the welding and cool down, the welded area and the surrounding material expand due to the rapid cooling and heating. So the second one is cooling. The material contracts during the cooling, and the different cooling rates of different zones of the material, as shown before, cause internal stresses and residual stresses. The next one is phase transformation. During the welding, the material phases changes, and we have different zones of welding which contribute to residual stresses. And one of the most important one is the mechanical constraint. The clamps, the fixtures, or everything else that holds the material steady and constrain the movement can cause residual stress after being removed. Because if we look at this shape, this welded shape, you see here the material was clamped in the grip, for instance, and the material wants to it is melted and it needs to be cooled down slowly, and it wants to expand or contract, and this grips doesn't let it to do that, and as a result it's going to distort and becomes a shape like this. So what effects can residual stresses cause? The first one is distortion. As I just said, it can bend the weld, like the shape you see right now, just before, and it can reduce the fatigue life because there is high stresses inside the weld, and in very low cyclic loading it can fail, and it might cause cracking, especially in the heat affected zone, or dimensional inaccuracies, which is the effect of the final dimension of the weld assembly, and we have fit up issues and we have to do the weld again. So how can we resolve this issue? Is to do the preheating. For instance, before welding, we can do the preheating. This preheating can slow down the cooling rate, so the material doesn't cool down faster while we're dealing with the material which is 20 degrees centigrade. And imagine that we do the welding while we did the preheating and it is already 100 degrees centigrade, and this can slower down the cooling rate, which is pretty useful and is one of the most widely managing processes in terms of residual stresses. The second one is post-weld heat treatment, or known as PWHT. They use that a lot after the weld was completed. They're going to heat that in order to release all those internal energies, and they cool it down in a transient way. The third one is pinning. Everything else that creates a minus stress, like this one. These stresses are in favor. We don't like it to be tension, so we want the pressure stresses, so we would like any process like pinning. So the next one is optimized welding sequences. So while we're dealing with multi-pass welding, we should optimize the process. We should let the material cool down, or we can use the temperature of the previous pass as a heat treatment to the second pass, and we have to optimize the time, the temperature, and everything else. And the last but not least is using low residual stress welding methods such as laser welding or electron beam welding, and other processes. So in this simulation, we are going to use the same MMAW example, the 3D one, and we are going to do the mechanical. We're going to check the mechanical option, and we want to do a mechanical simulation, and we see that the residual stresses would be a shape like this. So without wasting any time, we want to go to the simulation software.